Good day, everyone. This is Bongani Masango. I hope you are doing well and blessed wherever you are. I just want to say thank you so much, guys, for subscribing to our YouTube channel. And don't forget, if you haven't subscribed, to do so. And also share and like our YouTube videos. Thank you so much, guys. I've been looking forward to coming back. And yes, by God's grace, I managed to do so. Now, let's look at the topic that we're going to talk about today. These quantitative aspects of chemical change. All right. And we are going to be looking at the molar mass. All right. So the symbol that I've chosen there is capital M, as we can see there. And the SI unit, the measuring unit, or the standard international unit, it's grams per mole. Okay, and when we define molar mass, we are going to say it's a mass of a substance in 1 mole of that substance. So it's a mass in grams per mole. All right, so now we are going to look at the following examples and we'll be doing them together. All right, now I just want us to look at 1.1. As you guys can see there, what is the molar mass of aluminium? It is 27 grams per mole. Okay, and then the molar mass of nitrogen, it is 14 multiplied by 2, and that gives you 28 grams per mole. But I just want us to do aluminium first of all, and we're gonna do that together. Let's look at the periodic table. I hope you guys can clearly see wherever you are. We are having copper as our example. Copper is atomic number 29. And you can see the number on top there represents the atomic number. And you can see as well, the symbol for copper is capital C and the small letter U. Now, let me bring it to your attention. When you are having any element with 2 letters, okay, as your symbol, the first letter will be a capital letter and the second letter will be a small letter. So we are having 29 and then Cu there for copper, and underneath we are having another number there which is 63,5. That is what we call the molar mass. All right, you can see it's the approximate relative atomic mass. We are using that as our molar mass in grams per mole. Okay, and then on the left hand side of this box we are having electronegativity. All right, now I want to give some few examples. Let's look at number 27, which is cobalt. You can see the atomic number is 27. The symbol is capital C, small letter O, and then we have 59 there. So cobalt is molar mass is 59 grams per mole. Let's look at another example here. Let's look at boron. It's atomic number 5, and the molar mass for boron is 11 grams per mole. Let's look at carbon. The following element, it's capital C, atomic number is 6, molar mass is 12 grams per mole. Let's look at nitrogen. The molar mass for nitrogen, as you can see, it's 14 grams per mole. All right, now the first example that we chose is aluminium. Okay, and as you can see, aluminium, it is atomic number 13, and the molar mass for aluminium is 27 grams per mole. Okay, there we go. What is the molar mass for aluminium? It is 27 grams per mole. All right, now let's look at the following example, which is 1.2. You can see now it is diatomic element, and then 1.3 also it's a diatomic element, and now you see that aluminium is a monatomic element. Now when it comes to diatomic elements, all right, like nitrogen, it means there are 2 nitrogen atoms that are chemically bonded together to form a molecule. All right, so there are 2 atoms of nitrogen. Let's go to the periodic table. As you can see, here is our nitrogen here. It's atomic number 7, and its molar mass, it's 14 grams per mole. But this represents for an atom, not for two atoms. So this is one atom, okay, of nitrogen has a molar mass of 14 grams per mole. Now, how many atoms are we having here? 2. So we are going to take this 14 representing each atom, multiply by 2 for 2 atoms. As you can see, it's a diatomic element. So it's 14 by 2, which gives you 28 grams per mole. Okay, are you getting this? All right. Now let's try again. Nitrogen. Okay, what is the molar mass for each atom of oxygen? Let's look at oxygen. What is each molar mass? What is the molar mass for each oxygen atom? It is 16. All right, therefore it's going to be 16. How many atoms are we having? There are 2 atoms, therefore it's going to be 16 multiplied by 2, which will give us 32 grams per mole. Okay, as you can see, there are 2 atoms of oxygen. Right, now let's look at this compound. Now we are going to look for a molar mass of sodium chloride. Okay, now you must think about it. Now you need to know how many atoms are in this compound. All right, we know it's an ionic compound, it's a table salt. Okay, so let's look at sodium, which is number 11 on the periodic table. Here we go. We have sodium here, number 11. What is the molar mass of sodium of each sodium atom? It's 23 grams per mole. All right, so it's going to be 23 plus, what is the molar mass of chlorine? Each atom of chlorine, we are having 35.5 grams per mole. Remember, a chlorine gas is a diatomic element, okay? But now in this case, we have only 1 atom of chlorine, okay? Therefore, we are going to write 35.5. It gives us 58.5 grams per mole. Okay, so that is the molar mass of sodium chloride. Right, let's look at another example here. We've got sodium nitrate. Okay, let me just remind you, if you are struggling with naming, our first 2 videos, we were dealing with naming of compounds. All right, you can go back and check, you will get it right. Thank you. Now, sodium, as we have said, it is 23 plus nitrogen. As we have said, each atom has a molar mass of 14 plus oxygen. Okay, there are how many atoms of oxygen? There are 3, and each oxygen atom has a molar mass of 16, so it's 16 by 3. Okay, so you are going to have 23 plus 14 plus 16 times 3. Okay, so that is going to give you 85 grams per mole. Okay, I hope you are getting this right. Let's look at our last example. We are having aluminium sulfate. Please take note, this is Al, okay, 2, open bracket, SO4, close bracket, 3. I hope you can see clearly that it's aluminium sulfate. All right, now, what is the molar mass of aluminium sulfate? Remember, we said for each atom of aluminium is 27, but how many are we having here? We are having 27 times 2. There are 2 atoms of aluminium plus, okay, how many atoms of sulfur are we having? Now remember, everything inside the bracket is multiplied by 3, okay? It is multiplied by 3. So we are having 1 times 3. So 1 sulfur atom multiplied by 3. So there are 3 of them. All right, let's put that into our bracket. Sulfur, let's go and check sulfur. Sulfur is atomic number 32 grams per mole. So we are having 32 multiplied by 3 plus how many atoms of oxygen? There are 4 times 3. Just like we said 1 for sulfur times 3. Now there's a subscript or there's a number here, or there are 4 atoms of oxygen already. We times them by 3. That gives us how many? 12 atoms. Okay, is that right? So we are having 12 atoms of oxygen, and each oxygen atom has a molar mass of 16. There we go, it's 16 multiplied by 12. All right, now you can add everything together here after you multiply it, and then we are going to get 342. So you are going to get 342 grams per mole. All right, I hope you guys are getting these things right. All right, now I'm going to give you some activity for you to do. I hope you're going to get it right. All right, I'm going to give you some activities. Okay, here we go. I want you to try the following. This is our activity. Okay, and then there we go. I want you to calculate the molar mass of the following substances. Number 1, we are looking for the molar mass of zinc. And number 2, we're looking for the molar mass of calcium carbonate. Okay, do you want to try that? All right. Maybe let's add the third one. Let's add the molar mass of potassium permanganate. Okay. Do you want to try that? You can pause the video. You can pause this video and try that on your own. All right, let me give you the answers to that. Okay, sorry about that. Just hold on. Okay, sorry guys about that. Yeah, well, such things happen. Now, my apology. Let's look at zinc. What are we getting for zinc? And I hope you have your periodic table with you and you've tried this. All right, there we go. For zinc, I'm getting number 30, I'm getting 65 grams per mole. So the molar mass for zinc is what? It is 65 grams per mole. I hope you got that correct. All right. And then, what is the molar mass for calcium carbonate? What is the molar mass for calcium carbonate? And then let's look at calcium carbonate. Calcium, it is, where is calcium? Number 20 on the periodic table. It has a molar mass. It has a molar mass of 40. Okay, so this is going to be 40 plus, what is the molar mass of carbon? You remember? It's 12. Okay, so this is 40 plus 12 plus, how many atoms of oxygen are we having? 3. So each atom has a molar mass of 16. So this is 16 multiplied by 3. Okay, have we done something like this before? Okay, looks similar, but we haven't. Okay, so let's get the answer there. It's 16 by 3 plus 52. Okay, wait a minute. Plus 52, we are getting 100 grams per mole. Okay, so this gives us a molar mass of 100 grams per mole. All right, I advise you to use your calculator because you might think that you know the answer and sometimes you mess around there. All right, let's look at potassium permanganate. What is the molar mass of potassium? It is 39. We are only having one atom of potassium. All right, so it's going to be 39 plus. What is the molar mass of manganese? Okay, manganese is 25 on the periodic table. There we go. It is 55. All right, we're only having one atom, so it's 55 plus. How many atoms of oxygen are we having? We are having 4 of them, and each atom is giving us a molar mass of what? Remember, 16. Okay, 16 multiplied by 4. Okay, and then what are we going to get? Now you multiply everything and you add as well, so you're going to get 158 grams per mole. Okay guys, thank you so much. I hope you enjoyed, and I'm going to see you again next time. Thank you very much. Stay blessed.